This is section 9.3 in your class notes on page 8, and we'll be talking about infinite series. So the first part will be about the sum of infinite series. A sequence is a progression or an ordered list of numbers. A series is a numerical value when you add up all the terms of a sequence or a sum of a sequence. So the definition that's given here is an infinite series is an expression that can be written in the form summation of certain terms, and we'll call it as u of k, where k is equal to 0 or 1 and going out to infinity. So you have your first term of u of 1 plus the second term u of 2 plus the third term u of 3 plus all the way to the kth term. And then since it's infinite, it's going to keep going beyond that. So the numbers u1, u2, u3 are called the terms of the series. In most cases, we cannot actually calculate this infinite sum, even if we know that it exists. So we need to start by examining the sequence of partial sums. So let's consider this first example, where your first term is 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and then you're adding it all the way up to the nth term, a sub n plus, and then you keep continuing on to infinity. The first partial sum is the first term. The second partial sum is the sum of the first two terms, and the nth partial sum is the sum of the first n terms. So we have just written out a few of them. So the first sum is just going to be the first term, which is 1/2. The second sum is going to be 1/2, and then you're going to take the second one, which is 1/4, and add them up together. So that will be 3/4. And then the third partial sum is the first, second, and the third added together. So that would be 1/2 plus 1/4 plus 1/8. And so I just got a common denominator, and I end up with 7/8. And then you use the same pattern to figure out the fourth sum. So that will be 1/2 plus 1/4 plus 1/8 plus 1/16. And then get all the common denominators. 8/16 plus 4/16 plus 2/16 plus 1/16, and that gives you 15/16. So the question that should be asked is, what is the sum of all of the terms? So if you're going to be going from n is equal to 1, and then you're going out to infinity, and so it'll be 1/2, and then you're going to raise it to the nth power. So basically, from one term, first term to the second term, you're just multiplying it by a half. So the answer to this is going to be, what is the limit of s sub n as n goes out to infinity? And it comes out to be this. The common ratio is the second term a sub 2 divided by a sub 1. And so the second term is 1/4 over 1/2, and that is 1/2. So the sum is going to equal a over 1 minus r, and that is equal to 1/2 all over 1 minus 1/2, and that is equal to 1. And so we'll talk more about how you get this. There's actually a way that you could prove this. And now I want to show you on your calculator how you could do this. So if you could pull out your calculator. And I'm just going to follow this progression. There's actually a mistake on here. This 2 here should be an x. Okay, so this is an x. And down here, this power of 2 should be an x. That's an error there. Okay, so first thing is I want to add up the first 10 terms. So that will be the 10th partial sum. So I first find the sum, which is under second stat. Go to second stat, which is really your list, and then scroll over to math, And then down at number 5, it is sum. And then you want to call up the sequence. So same location, second stat, and then you go to OPS, which stands for operations, and then go down to sequence. And then you're going to put in your nth term. So I'll put in 1/2 raised to the nth power, which is the same thing as 0.5 and raised to the x power. And then you need a comma and then the variable that you're using, so that's x. And then I'm going to start off with my first term and go to my 10th term. Okay, so the answer I get is 0.99023. So I'll check the sum of the fourth partial sum. So that will be the fourth partial sum, that's S sub 4. And so I'm just going to do a recall and then change this last one to a 4 instead of a 10. And that gives me 0.9375. And so that should be equivalent to the one that I have up here, which is S sub 4. So I'll just put in 15 divided by 16, and that gives me the same answer. Okay, now if I want to figure out what is the infinite sum, then I can't put in infinity, but I'll put in a very large number, for example, 100. So let me just do recall 2 times. And so I'm using the same sequence, 1/2 raised to the x power, and then x, and then 1 out 2. And I'll just put a large number, like 100. So that means I'm adding up 100 terms, and then I enter, and I get 1 as the answer. Okay, so that is consistent with what I have right here. Okay, so let's look at some more definitions. So let S sub n be the sequence of partial sums of the series. So you have first term, second term, third term, all the way to the kth term, and then you're going to keep going. If the sequence S sub n converges to a limit S, then the series is said to converge to S, and S is called the sum of the series. So we're going to denote it by this. So notice that the only difference that we have right here is we're going S is equal to, K is equal to 1, all out to infinity of U of K. And if the sequence of partial sums diverges, then the series is said to diverge. And a divergent series has no sum. It usually goes to either infinity, a negative infinity, or it'll oscillate between 2 values. Okay, let's move on to page 9. Okay, so on page 9, we're going to define a geometric series. And it's a geometric series if you have a term a, the nth term is a r to the k. So starting from k is equal to 0 out to infinity. So you're starting with a, that's the first term, plus the second term, which is ar, plus the third term, ar to the third or second power, plus, and then you go to the kth term, which is ar to the k. And it converges if this absolute value of r, this is called the common ratio, is less than 1. And then if it diverges if the absolute value of r is greater than or equal to 1. So if the series converges, then the sum is going to be a divided by 1 minus r. So a represents the first term, and then r is the common ratio. Right? So it has to be true that the common ratio is absolute value is less than 1, or else this will not work. Okay, so I want to actually show you the proof of this. So you could write this down on a separate sheet of paper. So would you pause the video and just go get a separate sheet of paper, and I want you to write this down. All right, so here's the proof of the sum of the geometric series. And so let's first of all find the partial sum. So I'll say S sub n is equal to the finite sum. So the first step is I'm going to write out the nth partial sum, so S sub n. So this is the first term A plus the second term AR. So this is the first term, and then you're going to multiply it by the common ratio, plus the third term AR squared, plus the fourth term AR to the third, and I'm going to take it all the way out to the nth term. So this right here is the nth term, is AR to the n minus 1. All right, next thing is I'm going to multiply the entire equation by r. So on the left side, it'll be r times the sum of the n terms, S sub n, equals, and then to every single term up above, I'm going to multiply it by r. So that gives me a times r, so that's from this, and then plus ar squared, that comes from this, and then AR to the third, that comes from this. And then I'll go to the term that's right previous to AR to the n minus 1, which is really AR to the n minus 2. And if you multiply it by R on that, you'll get AR to the n minus 1. And then this one, if you multiply it by AR to the n minus 1 times an R, you'll get AR to the nth. Okay, so this whole line, I'm just multiplying the entire step 1 equation by r. Okay, now I'm going to subtract 2 equations. Right, so I'm taking the first equation here and subtracting off the second. And what you'll notice is that besides the beginning, so here's the beginning one, and then all the ones in the middle, see how these are exactly the same? So these are the same, these are the same, and these are the same, and these are the same. So what's left is the first one in the first equation, and then the last one in the second equation. So that gives me, on the right side, a minus ar to the nth power. Okay, so now I'm going to multiply, or the factor out common factors in each one of them. So on the left side, I can factor out an S sub n, and so I'm left with 1 minus r. And then on the right side, I'm left with, or factor out an a, and I'm left with 1 minus r to the nth power. Okay, and then I'm going to solve for S sub n. So if I solve for S sub n, on the right side, I just keep it as it is, and then I divide through by 1 minus r. So I get this. So if you recall, this is the sum of a finite geometric series. Right? So if I had like 100 here, or 10, or 5, I could use this formula. All right, now I'm interested in finding the infinite sum, meaning that n is going to go out to infinity. So this is the infinite sum. So I need to make a restriction on the common ratio. So it has to be r is, absolute value of r has to be less than 1. Okay, so I'm going to just start with now this formula right here above. So S sub n is equal to this. So I'll just write it as, now I'm going to make n go out to infinity. So I have the limit of S sub n as n goes out to infinity, and then I just put the limit out in front of this here, ratio. And remember that r is, absolute value of r is less than 1. So when I take n out to infinity for this particular part right here, r to the nth power, actually r raised to the infinity of something that is a fraction. So for example, this might be something like a half. So if I take 1/2 and raise it to a very large number, that's going to eventually go to 0. So we can see that any common ratio whose absolute value is less than 1, if you raise it to the infinity power, then it's going to go to 0. So basically this part here is going to drop out. And then if you put it all together, you have sum is equal to your first term, so that's a, divided by 1 minus r. Okay, so hopefully that's helpful to see where that formula came from and we got to the source. All right, let's go back to our class notes and we're going to do some examples now. Okay, so in example 2, the question is asking you to determine whether the geometric series converges or diverges, and if it converges, find the sum. So for geometric series, the main thing you have to do is just to find out what is the common ratio. Okay, so I'm going to attempt to do that first. So let's look at this part right here. So since it's starting at 0, a sub 0, that's the first term. And then I'm just going to put in 0 for k, so I get 5 over 4 to the 0. And then my second term, which is a sub 1, is equal to 5 over 4. So I get the common ratio is r is equal to a sub 1 divided by a sub 0, right? So in general, actually you should write this down here. So r is equal to a particular term, so it's going to be a sub n, and then you're going to divide it by the previous term, a sub n minus 1. Or you could write it as a sub n plus 1 divided by a sub n. So you take a current term and then you're going to divide it by the previous. So I get the common ratio to be 1/4, which is less than 1, so I know that it converges. All right, so you can get that answer about converging and diverging by the r value. Then I'll use the formula for the sum that I derived. So sum is equal to the first term, a, divided by 1 minus r, and then that is equal to 5 divided by 1 minus, and then the common ratio is 1 over 4, and that is equal to 5 times 4/3, so the sum is 20 over 3. Okay. All right. So for the next example, my first term is a sub 1 because it's starting with a lower index of k is equal to 1. And so my first term is 3 to the second times 5 to the 0, which is 9. And then my second term is a sub 2 is 3 to the fourth times 5 to the negative 1, which is equal to 81 over 5. So my ratio, common ratio, is second term a sub 2 divided by a sub 1. And when I simplify that, it becomes 9/5. Right? 81 over 5 times 1 over 9 is 9/5. And so that is greater than or equal to 1. So then this series, geometric series, it diverges. So when it diverges, I don't need to figure out what the sum is. I just stop at that. Okay, actually, let me have you turn off the video, and I'd like you to try the next two, C and D, and then come back after you've worked it out and then check your answer. All right, so for C, check your answer. I get a sub 1, and that is equal to 1/4. A sub 2 is equal to 1/8. So my common ratio is a sub 2 divided by a sub 1. It comes out to be a half, which is less than 1, so it converges. And then I just use my formula, a over 1 minus r, and then work out the arithmetic, and I get the sum to be 1/2. Okay, and then the next one that I asked you to try was this one. So for this one, your first term is 9/4, and then your second term is negative 27 over 8. So the common ratio here is a sub 2 divided by a sub 1, so it comes out to be a negative 3/2. And since the absolute value of that is greater than or equal to 1, it diverges. So there is no sum. Okay, if you think of repeated decimals, you can find the rational number that is represented by the repeated decimal. All right, so the way that you'll do this problem is to think of this as an infinite geometric sum. So I can rewrite this 0.515151 repeating as 0.51 plus 0.0051 plus 0.000051, and then I could continue on with that. So this is a geometric series, and I can see that the first term is 0.51, the second term is 0.0051, and then you have your common ratio, which is a sub 2 divided by a sub 1, so that comes out to 0.01, which is less than 1, so that's the common ratio, so that means it converges. So then to calculate the sum on this, you'd be taking a divided by 1 minus r. So the first term is 0.51, and then divide that by 1 minus, the common ratio is 0.01, and so it comes out to 51 over 99, or 0.51 divided by 0.99, and that is equal to 51 over 99. Okay, the next example, we are on page 10 now. It says use a geometric series to show that this series here is true if -1 is less than x is less than 1. Okay, so you want to show when it converges. So my first term is a sub 0 is equal to 1. And then my second term, notice it has the x in it, so I need to keep that. So that will be a sub 1 is equal to negative x squared. Right, so I'm just putting in 1 for all of my k's. And then a sub 2 is equal to x to the fourth power. So my common ratio here is a sub 1 divided by a sub 0. And you'll get the same thing if you do a sub 2 divided by a sub 1. So S is equal to A over 1 minus R, which is the same thing as 1 over, and then in place of my R, I'm going to put in a negative x squared, so that gives me a 1 plus x squared. Okay, so in order to converge, I know that the absolute value of R has to be less than 1. So then I'm going to put in my r, which is negative x squared, and I'm going to set up an inequality where the absolute value of negative x squared is less than 1. So that means that x squared has to be, absolute value of x squared has to be less than 1, which means that absolute value of x has to be less than 1. So then if you solve this inequality, that means that -1 is less than x is less than 1. And that's the proof. Okay, for example 5, it says find all the values of x for which the series converges. And then you want to find the sum of the series for those x values. All right, so for this one, I wrote it out that these are all geometric series. And so the first thing is I just want to write it out so that I factored out an x for the first one. So you have x minus x cubed plus x to the fifth, so they all have x's with it. And so to calculate my common ratio, I know that I'm going to take my second term divided by my first term. So my common ratio is a negative x squared. Then I'm going to write this as my summation. So I know it's going, n is equal to 1 all the way to infinity. And you're starting with x, and then you have multiplied by a negative x squared to the nth power. Right, so this is my first term, and this right here is my common ratio, and I'm taking it to the nth power. And so that is converging when the common ratio is less than 1. Right, so then I just go through the same procedure, and this calculation right here is real similar to what I have in example 4. Right, so absolute value of x squared is less than 1, so absolute value of x is less than 1, and then you have -1 is less than x is less than 1. So then to find the sum, I'll take the formula a over 1 minus r. So my first term is x, and then my common ratio is a negative x squared. So it'll be 1 minus a negative x squared, so it's 1 plus x squared. Okay, so the last example for the geometric series is this right here. And I'm going to first of all write it as r is equal to, so my second term is a sub 2 divided by a sub 1. So my common ratio is negative 1/2 x squared sine squared x over sine of x. And so my common ratio comes out to a negative sine of x over 2. And I can write the general term as this with my sigma notation. So n is equal to 1 out to infinity. And since this is alternating signs, I know that it has to be a negative 1, and then I'm going to raise it to the n minus 1 power. Since it starts at 1 and it's a positive, it has to be either a n minus 1 or n plus 1. And then in the denominator, I have a 2 raised to the nth power, and then the numerator, I have sine of x raised to the nth power. Okay, so the common ratio is less than 1. Absolute value of r is less than 1 when it converges. So I just write in my ratio of a negative sine of x over 2, and then I put that in absolute value and make it less than 1. So the absolute value of sine of x is less than 1. Divided by 2 is less than 1. So then I multiply through by 2, and then I get negative x is, or negative 2 is less than sine of x is less than 2, which actually covers for everything because I know that the range of sine of x goes from a negative 1 to 1, so this definitely covers it. So this would be true for all x's. And then the sum is a over 1 minus r. So the numerator has the first term, which is the sine of x, and then it's 1 over, or I'm sorry, 1 plus, and then the common ratio is a negative sine of x over 2. So then work that out, and I get my sum to be 2 sine of x over 2 plus sine of x.